Hello, hi everyone. I am going to discuss about the chapter acid, base and salt of 10th class of chemistry chapter. So, introduction first is introduction. Element combine to form a numerous compounds on the basis of their chemical properties. Compound can be classified into three categories: acid, base and salts. Acid and bases in the laboratory. Indicators, common indicators and olfactory indicators, which are in the laboratory, the use of the acids and bases. The indicators and indicator tells us whether a substance is acidic or basic in nature by the change in color. The compound is acidic or basic in nature by the change of the color through the indicator. The substances by the substances nature by the acidic or basic. It tells about the nature of the compound, whether it is acidic or basic. Common indicator: an acid turns blue litmus red, and base b- turns red litmus to blue litmus paper. Methyl orange indicator gives a red color in the acidic solution and gives yellow color in the basic solution. Phenolphthalein is colorless in acidic solution and gives a pink color in the basic solution. Olfactory indicator: those substances whose odor changes in acidic or basic media are called olfactory indicator. For example, onion, vanilla, and the clove oil. Odor changes in acidic or basic media as the is are called the olfactory indicators. On adding sodium hydroxide solution to a cloth strip treats with onion, the smell of the onion is not detected. An acidic solution does not eliminate the smell of the onion. अनियन का स्मेल नहीं निकलता जैसे ही हम ऐड करते हैं सोडियम हाइड्रोक्साइड सॉल्यूशन टू द स्ट्रिप कॉटन स्ट्रिप ट्रीटेड विद द ऑनियन. तो smell of the onion is not detected and the acidic solution does not eliminate the smell of the onion. It indicates the solution is acidic or basic medium it by the olfactory indicators. Reaction of the acidic and basic reaction of the acids and bases with metals. Acid reacts with metal to produce salt by displacing hydrogen. For example, when dilute sulfuric acid reacts with the metal zinc, zinc sulfate is formed with the evolution of the hydrogen gases. For example, Zn when reacts with the H2SO4 it gives ZnSO4 and evolution of the hydrogen gas. Zinc is the only metal which reacts with the sodium hydroxide to form sodium zincate with the reaction of the hydrogen gas. Zinc gives zinc reacts with the sodium hydroxide 2 moles of the sodium hydroxide it gives sodium zincate Na2ZnO2 plus H2. Reaction of metal carbonates and bicarbonates with the acids. Acid reacts with the metal carbonates or bicarbonates to form salt and water with the evolution of carbon dioxide gases. For example, hydrog- hydrochloric acid reacts with the sodium carbonate to give sodium chloride and water with the release of carbon dioxide gases. Na2CO3 plus 2Cl 2HCl aqueous gives 2NaCl aqueous plus CO2 gas plus H2O liquid. Similarly, sodium bicarbonate reacts with hydrochloric acid to form sodium chloride and water with the release of carbon dioxide gases. With the release of carbon dioxide gases, NaHCO3 solid plus HCl, which is acid aqueous, gives NaCl aqueous plus CO2 gas plus H2O liquid. Neutralization. The reaction between the acid and a base to form salt and water is called a neutralization reaction. When the reaction is between the acid and base to form salt and water is called the neutralization reaction. For example, hydrochloric acid reacts with a hydroxide to form sodium chloride and water. HCl reacts with the NaOH, which is base. Acid plus base gives salt NaCl plus water. H2O releases. Reaction of metallic oxide with acid. Acid reacts with metallic oxide to form salt and water. For example, copper oxide 2, a black metal oxide reacts with dilute hydrochloric acid to form a blue-green colored copper chloride solution. CuO reacts with 2 moles of HCl reacts and gives CuCl2 aqueous plus H2O. Reaction of non-metallic oxide with base. The base reacts with non-metallic oxide to form salt and water. For example, calcium hydroxide reacts with non-metallic oxide like carbon dioxide to form carbon dioxide, salt and water. NaOH2 plus CO2 gives calcium carbonate plus water. Calcium carbonate plus water. Acid and base in water. Acid is a substances which dissociated or ionizes when dissolved in water to release hydrogen ions. For example, an aqueous solution of hydrochloric acid dissolves to form hydrogen ions. Since ions do not exist as hydrogen H plus in the solution, they combine with water molecule to form hydronium ions H3O plus. HCl gives HCl aqueous gives H plus aqueous plus Cl minus aqueous. H, H plus H2O gives H3O plus. The presence of hydrogen ions H plus in hydrochloric acid solution makes it behave like an acid. Bases. A base is a substances which dissolve in water to produce hydroxide ions, OH ions. The bases which are dissolved, which are soluble in water are called alkalis. For example, sodium hydroxide gives in water to produce hydroxide and sodium ions. NaOH aqueous plus gives Na plus aqueous plus OH aqueous. The presence of hydroxide ion OH minus in sodium hydroxide solution gives its it behave like a base. pH scale. A pH scale of a solution. pH of the solution is a negative logarithm to the base 10 of the hydrogen ions concentration expression in mole per liter. ये pH दे रखी है equals to minus log 10 H plus ions. pH is if 7 neutral, pH less than 7 acidic, pH more than 7 is basic. OH H plus ions equals to OH ions, OH minus ions. OH plus ions is more than OH ions in acidic. OH ions is more than H plus ions in basic. pH scale is a scale showing the relative strength of the acidic and alkalis acids and alkalis. The normal pH scales range 0 to 14 as given below. Universal indicator. In case of a colorless liquid, the accurate pH can be obtained by adding a universal indicator. It is a mixture of several indicators and shows different colors at different concentration of ions hydrogen ions in a solution. For example, a universal indicator produces green color in a neutral solution pH 7. The color changes from blue to violet as pH increases from 7 to 14. The color changes from yellow to pink and then to red as pH decreases from 7 to 1. Importance of pH in everyday life. pH changes and several of animal. Our body works well within a narrow pH range of 7.0 to 7.8. When the pH of rainwater is less than 5.6, it is known as acid rain. When the acid rain flows into river, it flows it lowers the pH of the river water, making the several of the aquatic life and difficult. The pH in our digestive system. Our stomach produces hydrochloric acid, which helps in the digestion of food without harming the stomach. Sometimes excess acid is produced in the water in the stomach, which causes indigestion. To get rid of this pain, base called antacid are used. Antacid are a group of mild base which reacts with the excess acid and neutralize it. Commonly used antacid are magnesium hydroxide MgOH2, magnesium bicarbonate, NaHCO3. pH change Cause of tooth decay. Tooth decay starts when the pH of the mouth falls below 5.5. Tooth enamel Tooth enamel is made up of calcium phosphate, which is the hardest substances in the body. It is insoluble in water but gets corroded when the pH of the pH in the mouth fall below 5.5. The bacteria present in the mouth produce acid due to the degradation de- degradation of sugar and food particles after eating. Hence, to prevent tooth decay, the mouth should be rinsed after eating food, and toothpaste, which are basic, should be used cleaning teeth to neutralize the excess acid. More about salt. Salt having some positive ions and some negative ions are said to belong belong to the belong to a family of salts. pH of salts of strong acid and a strong base are neutral with a pH value of 7. And for example, Na, NaCl, Na2SO4, salt of strong acid and weak base are acidic with the pH value less than 7. For example, ammonium chloride solution has pH value of 6. Salt of weak acid and strong base are basic with pH value more than 7. For example, sodium carbonate solution has a pH value of 7. Common salt, chemical name sodium chloride. Common salt is a neutral salt and can be prepared in the laboratory by the reaction of sodium hydroxide and sodium chloride. NaOH aqueous plus HCl aqueous gives NaCl aqueous plus H2O aqueous. It is an important raw material for products of daily use such as NaOH, baking soda, water, washing soda, and bleaching powder. Sodium hydroxide. Sodium hydroxide is produced by the electrolysis of a aqueous solution of sodium chloride called brine. The process is called the chlor-alkali process because of the product formed chlor chlor for chlorine and alkali for sodium hydroxide. 2 moles of NaCl aqueous gives reacts with the 2 moles of hydrogen hydroxide water H2O aqueous water gives Na 2 moles of NaOH aqueous plus H2 H2 gas and gives Cl2 gas. This is the solution in which two electrodes are there, brine and is sodium chloride solution brine, and hydrogen gas is evolving in the brine, and chlorine gas is evolving and their solution is sodium hydroxide solution. and there is battery connected. There is formation of acid and base. Bleaching powder. Bleaching powder is manufactured from chlorine gas. It is produced by the action of chlorine on dry scale, slag, slake lime, calcium hydroxide ions. Calcium hydroxide plus Cl2 gives calcium OH, calcium OCl plus H2O. It is represented as CaOCl2, used for for bleaching cotton and linen in the textile industry and for bleaching wood pulp in the paper industry. Baking soda. Chemical formula sodium hydrogen carbonate NaHCO3. It is produced on a large scale by treating chloride and concentrated solution of sodium chloride brine with ammonium and hydrogen carbon dioxide NaCl plus H2O plus CO2 plus NH3 gives NH4Cl plus and NaHCO3. On heating, it decomposes to gives carbonate with the evolution of sodium by sodium carbon dioxide. Sorry, evolution of the carbon dioxide to NaHCO3 gives heating Na2CO3 plus H2O plus CO2 evolution of CO2 gas. Use as anti-acid to treat acidity of the stomach. Used as to make bleaching powder to make baking powder, which is used in the preparation of cakes and bread, etc. Used in soda acid fire exhauster exhauster exhaustion. Washing soda. Chemical formula Na2CO3 10H2O. Sodium hydrogen carbonate on heating decomposes to give sodium carbonate with the release of hydrogen gas. Recrystallization of sodium carbonate produces washing soda NaHCO3 on heating gives Na2CO3 plus H2O plus CO2. Na2CO3 plus 10H2O gives Na2CO3 10H2O. Uses used in glass, soap and paper industries, employed in the manufacture of sodium compounds such as borax. Water of crystallization. Water molecules which form a part of the structure of crystal are called water of crystallization. The salt which contain water of crystallization are called hydrated salt. Every hydrated salt has a fixed number of molecules of crystallization in its one formula unit. For example, CuSO4 5H2O, Na2CO3 10H2O, CaSO4 5H2O and FeSO4 7H2O. Copper sulfate crystals CuSO4 5H2O are blue in color. On heating, they lose all the water of crystallization and form anhydrous copper sulfate, which is white. On adding water to an anhydrous copper sulfate, it gives hydrated and turns blue. CuSO4 5H2O on heating gives CuSO4 plus 5H2O. CuSO4 plus 5H2O gives on heating CuSO4 5H2O molecule. The last is plaster of Paris. Plaster of Paris is prepared by heating gypsum at 373 K. On heating, it loses water molecules and become calcium sulfate, hemihydrated calcium sulfate half H2O, which is called plaster of Paris. CaSO4 2H2O gypsum on heating gives CaSO4 half H2O plaster of Paris plus 1.5 water. Used in hospital as plaster for supporting fractured bone in the right position. Used as a fireproofing material. My video is completed, and like, share and subscribe my video. Thank you and have a nice day. And please subscribe my video and thumbs up and like on like button.